Alright, good morning class and welcome. Today we're just going to go through some different Regents volume problems just to kind of see how they work, and we're also going to see something today called, not really a good name for it, but to see how we can take a 2D shape and rotate it and create a three-dimensional shape. So that's what we're going to be looking at today. Once you complete this video, you again will have the blank reference, you'll have the blank version of this PDF available. So if you have a printer, you could print it out. If not, you can just follow along on a separate sheet of paper. So you follow along with this video first, then you'll be able to try the other sheet on your own, and you'll have a couple of days to do that, and that'll all be up on the Google Classroom. So question number 1, a manufacturer is designing a new container for their chocolate-covered almonds. Their original container was a cylinder with a height of 18 centimeters and a diameter of 14 centimeters. The new container will be modeled by a rectangular prism with a square base and will contain the same amount of chocolate-covered almonds. If the new container's height is 16 centimeters, determine and state to the nearest tenth of a centimeter the side length of the new container if both containers contain the same amount of almonds. So now we're not going to be doing this by the number of almonds. There were 27 almonds. We'll be doing this by the volume of almonds, considering an almond weighs so much per volume. Now, so there's a second part to this question right here. We're going to hold off on that and just figure out the first part. So we have here our x and our x. How did I get that? We know the base is a square, okay? Now, they gave us the height of 16, so that third dimension there is going to be 16. So first thing we want to do here is actually find the volume of the cylinder. Okay, so I'm going to call that VC, and that's going to be the volume of the cylinder. Now, you go to your formula sheet. Remember, that's posted as a reference on the Google Classroom, but the formula sheet for a cylinder, the volume is going to be pi r squared h. Okay, and when we go to find the volume of our cylinder, okay, we're going to get pi. Now, you got to be careful here. It is going to be 7 squared. Remember, we are given the diameter. We need the radius. And then the height is going to be 18. Now, I'm going to be asked to use the nearest tenth of a centimeter. So I'm going to be careful that when I plug in, I use the pi button on the calculator. So I'm going to plug in pi times 7 squared times 18. And I'm going to round this actually beyond what I need to round to. I'm going to round 2770, and I'm going to do 0.885. Now you might say, well, it says nearest tenth. Why did you round to the nearest thousandth? Because this is not my final answer, and I want to wait till the very end to get my final answer. So now on the other side, we have the volume of a rectangular prism where the base is a square. And if you remember, the volume formula for a prism is capital B times H, where that B represents the volume of the base. So there I'm going to have the volume of my prism. And the volume of my prism, the base is a square, meaning that I'm going to have side squared times H. My sides are x and x, so for the volume of my prism, I'm going to have x squared times 16. Now we know we're being told that even though they changed the shape of the box, we want those volumes to be the same. So now we're going to set 2770.885 equal to x squared times 16. Now, they said to round to the nearest tenth of a centimeter. By keeping those extra decimal places there, we make sure we didn't have a rounding error when we solve for x, because it's x, the length and the width of the new container, that are going to be very helpful to us. Okay, so let's take a look here. So we're going to divide by 16 on both sides. And that'll give me that x squared is equal to, so I'm going to have 2770.885, and you could also use the second answer button on your calculator. This would be a very effective method, right? And that's going to give me 173.180. Again, sticking to my nearest thousandth, because now what I'm going to do is now I'm going to take the square root of both sides, and here's where I want to round to the nearest tenth. Okay, so again, no square root second answer, and I'm going to get 13.2. Okay, so I've got my length of 13.2. Now that only answers this first part of the question. The next part of the question says a store owner who sells the chocolate covered almonds displays them on a shelf whose dimensions are 80 by 60. The shelf can only hold one layer of new containers when each container sits on its square base. Determine and state the maximum number of new containers the store owner can fit on the shelf. Okay, this is where you really got to think here. You think that this is a volume question. It was a volume question. This new part here, this second part of the question, is an area question. Okay, we've got our base of our shelf that is 60 by 80 long. Okay, it's an area. So when we find the area of a rectangle, we're going to say that this has 4,800 square centimeters. Okay, right? This is cm squared of area. These are being stood up on the base. The base is a square, and so that base is 13.2 by 13.2. So the area of each one of these is going to be 13.2 squared, which is 174.24. And then basically what we're going to do here to answer the second part of this question is we're going to be dividing that 4,800 by the 174.24 to see how many of these square bases we could fit onto this 4,800 centimeter square area platform. Okay, so we're going to take 4,800. Again, if you can use the second answer button, going to be very effective. So we get 27.5. Okay, and I'm rounding there. Now the problem is I can't have half of a container, okay? So I can only fit 27 containers on that shelf. Okay, so what started as a volume problem, the second part of it became an area problem. So I have my two answers. I have the length, and then I have how many containers I could fit on the shelf. A lot of work there, but again, very simple work, all based on formulas, all based on plugging in. Very doable, but you have to sit down and take that time. All right, question number 2. If a rectangle is continuously rotated around one of its sides, what is the three-dimensional figure formed? Okay, so we really haven't talked about anything like this. This is really just a visualization question. So what we're going to do is we're going to draw a rectangle. And I want you to imagine that we take one of its sides. So what I'm going to do here is take one of the sides and color over it with red. That is going to stay fixed. And what's going to happen is we're going to take the rest of it and revolve it around that piece. So imagine if you took a piece of paper and you held one edge with your fingers and you rotated the other edge around in a circle about that line. And that's what we're going to do. So this is going to come around. And what you should see is that you're actually going to end up with a cylinder if you look at the shape that's going to be made, right? This rectangle here, continuously rotated around, will create a cylinder, okay, because we are rotating. Okay, that's the key word there. Okay, it's not going to form a sphere. It's not going to form a cone. Not going to form a rectangular prism. Okay. Again, it's just something, can you visualize what is happening with these pictures? Okay. 3. What is the volume of a hemisphere that has a diameter of 12.6 to the nearest tenth of a cubic centimeter? Okay, so a hemisphere is like a sphere, but it's half of a sphere, right? If you think about like the northern hemisphere and the southern hemisphere when you were in geography or in social studies class. So we could start by considering a sphere, but we're only going to be considering the top portion of that sphere. We're not going to consider the bottom. So we go to our formula sheet, okay, and you can look on your formula sheet and see that the volume of a sphere is 4/3 pi r cubed. Now we have half of that, So we're going to have 1/2 times 4/3 times pi times r cubed. We're rounding to the nearest tenth. And the other part that we have to take into account is they've told us the diameter is 12.6. Remember, our formula needs radius, so we need to use 6.3. Okay, so we're going to use that radius of 6.3. So the volume is equal to 1/2 times 4/3 times pi times 6.3 to the third power. And we can plug all of that into our calculator. Okay, make sure you have parentheses. And when we multiply all this together, we will get our answer. Make sure that you are using the pi button. We never use 3.14 or anything like that anymore. So just be careful. Okay, when we plug that in, we get 523.697. They wanted me to round to the nearest tenth, so the volume will be 523.7, which is choice A. All right, number 4, square math. So I have a square, and I know that it's called math. Has a side length of 7 inches. Okay, since it's a square, we know that every side will be 7 inches. Which three-dimensional object will be formed by continuously rotating square math around side AT? So, okay, again, we're going to create that one red side. They told us AT is what's being rotated. So if we're rotating this way, we're still going to get that cylinder shape. Okay, we're still going to get that cylinder shape. If you think about the way the center is rotated, that'll be 7. The height will also be 7. Okay, so it's going to be a right cylinder. So we know we can eliminate choices A and C. Now the question is the diameter going to be 7 or is the radius going to be 7? And because we're rotating around, ultimately we'll end up with another 7 over here. Our diameter would be 14, so our radius is going to be 7, choice D. You really got to draw these pictures out if you want to know what's going on. Okay, I know I said it in class all the time, but if you're not drawing these pictures, there's no way you're going to be able to get this. All right, a cargo trailer pictured below can be modeled by a rectangular prism and a triangular prism. Inside the trailer, the rectangular prism measures 6 feet by 10 feet. The walls that form the triangular prism each measure 4 feet. Okay, the diagram below is of the floor, showing the inside measurements. If the inside height of a trailer, they want the volume of the trailer. Okay, so let's talk about how we're going to do this here. We know that this is 6. Okay, we know the entire distance here is 6, meaning that this is 3 and this is 3. Now we know that this is going to be a 90-degree angle in here, okay? And so what's going to happen is I first have to start with this right triangle here where I have 3 and 4 and an unknown side. And what's going to happen here is I'm going to have to, we don't have a volume formula for a pentagon or anything like that. So what we're going to have to do is first find the volume of the rectangular prism that'll be created, and then find the volume of the triangular prism, and then we'll just add those together. So we're going to find 2 different volumes here. What I'm looking for here is my base is going to be 6 on that triangular prism. I need a height. And the Pythagorean Theorem will do that for us. So 3 squared plus x squared is equal to 4 squared. 9 plus x squared is equal to 16 minus 9 minus 9. X squared is equal to 7. So then x is going to be equal to radical 7. Okay, so let's start with the volume of the rectangle. The volume of the rectangular prism, and the volume for any prism, is B times H, where B is the volume of the base. Our base here for this rectangular prism is going to be this rectangle that I'm highlighting here in orange, so 6 foot by 10 foot. So our volume here is going to be 6 times 10 times that height of 6.5. Okay, and we'll multiply all that together to find the volume of the rectangular prism, and that's 390. Now we're going to do the volume of the triangular prism. Okay, again, volume formula is still B times H, except the base, I should say, of this triangular prism is 1/2 the base of 6 times the height, which we found to be radical 7, times the height of the trailer, which is 6.5. So we've got two heights going on here. One is the height of the triangular base that I'm highlighting here in orange. One is the height of the trailer here, which is 6.5. Okay, we're going to plug that into our formula. So 1/2 times 6 times radical 7. Now you might say, well, could we plug that radical 7 in first? There really is no point to doing that, because then we're just going to probably be rounding. We don't want to do that. So I've got a volume here of 51.6. I believe they said to the nearest cubic foot. So then when we add these, 390 plus 51.6, we're going to get 441.6, which will round to 442. And this is volume, so it's going to be feet cubed. Okay. So we're going to do something very similar with problem number 6. So a vendor is using an 8-foot by 8-foot tent. Okay, for a craft fair, the legs of the tent are 9 feet tall, and the top forms a square pyramid with a height of 3. So we have a rectangular prism at our base, and we have a square pyramid also. So we're going to have to break this up. So let's start with the volume of our rectangular prism, which is really a square prism, but same thing. The area of our base is going to be 8 times 8, and then our height is going to be 9. And we end up with 576 cubic feet. Now for the volume of our square pyramid, okay, our square pyramid, we actually have a formula for a pyramid, okay, and the volume is 1/3 capital B times H, and remember, capital B stands for the area of the base. Now, this is a perfect square here, so this is still 8, and this is still 8, so our volume of our square pyramid will be 1/3 8 times 8, and then our height, it's the height of the pyramid, which is 3. So we'll plug that into our calculator. Okay, we'll do 1/3 times 64 times 3. And what's really nice here, again, maybe you realize it, maybe you don't. Either way, the calculator will tell you, but that 1/3 and that 3 are going to cancel out with each other. So you're just going to get 64 cubic feet. Now they want the volume of the entire space the tent occupies, so you'll be doing 576 plus 64, and you're going to get 640 cubic feet, and that is choice B. Okay, so 9 questions in total here, so at any point, again, if you have to pause the video, stop the video, please feel free to do so. Okay, for number 7, we have a cone. We're given the radius, and we're given its slant height. Okay, be careful here, because they're asking you for the volume of the cone. The cone formula, the volume that we have, is 1/3 pi r squared h. Now this comes from our formula sheet. We know what the radius is. Okay, the radius is 2.5. What we don't know is the actual height. This is what's known as the slant height. But again, it's seeing what the picture has. I've got a right triangle here. I may not know what h is, but I know what 2 of the other sides of a right triangle are. And so what I can do is I can use the Pythagorean Theorem to find the h that I need from my formula here. Okay, so what we're going to end up with here is we're going to look at let's find the Pythagorean theorem first. So a squared plus b squared equals c squared. H squared plus 2.5 squared is equal to 6.5 squared. H squared plus, okay, so 2.5 squared is 6.25. And 6.5 squared is 42.25. So when I subtract my 6.25 from each side, I end up with h squared is 36, square root both sides, h equals 6. So I now know that my height is 6. Now I can come back and just plug into my volume formula. Volume is 1/3 pi. My radius is 2.5 squared, and my height is 6. And I'm going to plug that right into my calculator. Now, one thing I find is a lot of students always forget to put that squared in. You're so fixated on plugging in the r that you forget the little power on the r. So just be careful with that, okay? Go slow, no rush here. You know, definitely have your time, take your time with these. These should be the ones that you definitely get on the Regents. Okay, now, one thing I didn't pick up on here right off the bat, right? I just plugged this into my calculator and got 39.3. Now that's great, but that's not an answer. You'll notice all the answers are in terms of pi. So I didn't want to plug this pi into my calculator. So let's try that one more time without plugging in the pi. And again, I leave these kind of mistakes in here. I don't even think they qualify as mistakes, but I want you to see the thought process, like how we actually go about this, right? Because it's not immediately clear. You have to kind of think back and say, like, okay, how can I take this one step at a time? So the 12.5 is what we get out of the calculator, and we leave that in terms of pi by tacking on a pi. So another good volume question. Every single question on this sheet was a past Regents question. Okay, the reason I want you to see these like this is that these are going to help you to determine, that you can conquer the Regents and that the Regents is very doable. Okay. So a walking path at a local park is modeled on the grid below, where the length of each grid square is 10 feet. Okay. The town needs to submit paperwork to pave the walking path to determine and state to the nearest square foot the area of the walking path. Okay. So the way this is going to work is we've actually got here is we're going to find two areas and we're going to subtract. Basically, we need to take the area of the big and subtract out the area of the small. We don't want to pave any of this region here that I'm cross-hatching. Okay, so we want to find the area of the big, and the other part of this that's pretty cool is we're going to split the page in half, area of the big, and we'll find the area of the small. Now, when you find each of these areas, you actually are finding the area of a rectangle and the area of a circle. Now you might say, wait a minute, we have two half circles. Yes, we have two half circles that are going to become one full circle. So we're going to find the area of the rectangle, and we're going to find the area of the circle, and then at the end we'll subtract each of those. So for the area of the big rectangle, I go from 70 to 10, making its width 60. And then I go from 30 to 120, making that 90. So I can multiply 60 times 90, and I get 5,400. Now for the area of the circle, I'm going to use a formula for pi r squared. Okay, now I'm going to leave this in terms of pi. Okay, so pi, and my radius here is going to be, let's draw it in red so you can see, my radius here is going to be 10, 20, 30. Okay, so 30 squared. So my radius here is going to be 900 pi. So that would make the area of the big 5,400 plus 900 pi. Now we go for the area of the small. The small rectangle has the same length, meaning it's still 90 long. But the height is now not 60. Okay, the height is now 10, 20, 30, 40. Is only 40 tall. But the area of the circle, still using that pi r squared formula, the radius for the smaller circle here is only going to be 20. So I'm going to get pi times 20 squared. So it's going to be 400 pi. So I didn't multiply the 40 times the 90. Let's do that. So I end up with 3,600. And so I get 3,600 plus 400 pi. So now I'm going to subtract these two answers. Oh, one too many 4s over here. Okay, so let's fix that. So just 5,400 plus 900 pi. Now you got to be careful here. You have to distribute the negative to both terms. Okay, make sure you're distributing that negative there. That's just common subtraction practice. Okay, so when I subtract, I'm going to subtract like terms. So 5,400 minus 3,600, that's going to give me 1,800. I'm going to put a little mark through them, not so I can't, see them anymore, but just so I know that I've used them. And then 900 pi minus 400 pi is 500 pi. So let's see in what terms they want the area, and they want it to the nearest square foot. So we're actually going to plug all this into the calculator. Okay, and what we're going to do is we're going to round to the nearest foot. So that's 3,371 feet squared. This is area, not volume. They didn't tell us how thick they needed the concrete or anything like that. So this is square footage. If you look back a couple of videos, we talked about the difference between like a 2-dimensional measurement and a 3-dimensional measurement. Okay, last question. Teresa has a rectangular pool, 30 feet long, 15 foot wide, 4 foot deep. Okay, so do our best to draw this picture. 4 feet deep, 30 feet long, and 15 feet wide. She fills her pool using city water at a rate of $3.95 per 100 gallons. Okay, we'll keep that in mind. Nancy has a circular pool with a diameter of 24 feet. Okay, so now we've got a circular pool. It's going to be a cylinder. Diameter is 24 feet. I'm going to go right to using the number 12 because I know that we want radius when we're finding the volume of a cylinder. Okay, so this is Teresa. We'll put a T there. This is Nancy. We'll put an N there. Okay, Nancy has a little bit more expensive water, but not really because she pays $200 per 6,000 gallons. So the unit is totally different, and so we're not 100% sure who's getting the better deal. So if Teresa and Nancy both fill their pools 6 inches from the top, so instead of 3 feet, this is the part, it's 3.5 feet. Because 6 inches is half of a foot. So this is, something you have to take into account. This is also going to be 3.5 feet. So you just got to be careful with that. So the first thing we need to do is find the volume. Then we can figure out the cost to fill up their specific pool. Okay, so volume here is going to be B times H. For us, the B is going to be 15 times 30 times 3.5. Here we're going to get volume equals pi r squared h. So for us, volume is pi. Remember, I already took that 12 and, 24 and made it a 12 because they gave me the diameter for Nancy's pool. So I already corrected for that. We're going to plug each of these into a calculator and see what we've got. So we've got 1575 cubic feet, and here we've got 1,583 cubic feet, and I'm rounding that there. Now, they told us that 1 cubic foot is 7.48 gallons. So first thing we need to do now is convert to gallons. So we're going to go from cubic feet to gallons. And the way we're going to do that is just by multiplying by 7.48. So that's going to be our next step for each problem here. And remember, it's not necessarily who has more gallons, right? It's who's getting the better deal here. So this is going to be 11,781 gallons. And we're going to have 11,841 gallons. Again, I'm rounding that there. Okay. So now we're going to set up a proportion for each. So for Teresa pays $3.95 for every 100 gallons. So when we set up a proportion, it's how much will she pay for her 11,781 gallons. Okay, and we could solve that. And then here we're going to set up, she pays $200 per 6,000 gallons. So again, the question is how much will she pay for 11,841 gallons? In each case, we're going to cross multiply and we're going to try and solve for how many gallons. So this becomes 100x. And then that's going to equal $3.95 times 11781. Going to divide by 100, and so it's going to cost Teresa $465.35. Remember, using money, we round to the nearest hundredth place. So then we'll multiply over here, we'll cross multiply. 6,000x is equal to, so I need to do 200 times 11841. Okay, and we end up, sorry about that there, we end up with 2368200. We divide by 6,000. And we get 394.7. Okay, determine and state. Determine and state. So we can't just determine it, we have to state who paid more to fill her pool. Okay, so Teresa paid more to fill her pool. Okay, if it asks you to state, make sure that you state. Okay, so there are 9 problems that I picked out from last 3 years or so of Regents's, okay? And hopefully this gives you a little insight into how some of these problems are going to be done. So the way this will work now is, now that you've watched this video, as many times as you need to watch this video, you'll have a few days to digest this and go through and try some problems on your own. Again, please use the Google Classroom as a sounding board, ask questions, why did you do this step on number 3? Or in the video at 2 minutes and 55 seconds, why did this happen? These are all great questions that you can ask. So if you have any questions at all, please let me know. All right. Hope everyone's doing well. Have a great day.